All right, so today we're going to look at subsets. It's not bad. It's pretty easy. So let's go ahead and get started. It says set A is a subset of set B expressed as. Okay, so A is a subset of B, and this is how it's written. It's kind of like a C with a line under it. It's not really a C. I guess more along the lines, it looks something like that. Something like that. All right. If every, oh, so okay. So A is a subset of B if every element in set A is also an element in set B. And the notation, it's this symbol here, but with a line through it, means that A is not a subset of B. All right, so talking about subsets and not a subset. So in order for A, in other words, what it's saying, in order for A to be a subset of B, all the elements of A have to be in B. All right, so let's look at example 1. It says write subset or not a subset in each blank to form a true statement. So here it has A and then a blank and B. So let's look at the elements of A and let's look at the elements of B, of set B. So you can see that the elements of A, let's see, we've got 1, and the element 1 is in B. All right, so, and then we have 3 is an element of A, and it's also an element of B. 5 is an element of A, and it's also an element of B. And then we have the element 7, and that's also in B. So you can see every element of A is also in B. So we would say that A is a subset of B. All right. So let's look at the part B. Now remember from the last lesson, these two sets are written using the roster method. And in these next two in example B, those are written in part B, those are written in set builder notation. All right. So we've got A is the set of all X such that X is a letter in the word proof. B is equal to the set of all Y such that Y is a letter in the word roof. So, there's a couple of ways you can do this. I think the easiest thing, since we don't have a lot of elements here, see the letters in the word, so I would just write this out as A is P R O F, and set B is the set R O F. All right. So all I did is I just listed the elements out using the roster method. And notice in both of them, the O appears twice. Well, I'm only going to write it once. Okay. So let's see. Is A subset or not a subset of B? Well, let's look. Well, right off the bat, we see P is in A, but it's not in B. So we can stop right there. So we can say that A is not a subset of B. Okay, even though, look, R is in both, O is, and F is. But remember, every element of A has to be in B, and it's not. The P is not in B. All right. So let's look at part C. So you can see here set A is written in set builder notation, and set B is in the roster method. Each element's listed out. So for A, that's the set of all X such that X is a planet of Earth's solar system. So that's all the planets in the solar system with the Earth. And set B is the set Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All right, well, what are all the planets in the solar system? Well, that's all of these that are listed in B. So every element of A is in B. So we would say that A is a subset of B. Okay. What is the set A if we list it out? Well, that's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And that's exactly the same set as B, so we say that they're subsets of each other. And if you remember from the last lesson, what else could we say? I know it doesn't ask this, but let's just look at it. We can also say that A and B are equal. They're equal sets. They have the exact same elements. And I know back when I was in school, Pluto was a planet, but then now it's not. So that's why Pluto's not listed. All right, so let's look at this statement here. Set A is a proper subset of set B, expressed A is a subset of B. All right, so basically all it is, it's the same symbol as this, it just doesn't have the line underneath it. Okay, so A is a subset of B if set A is a subset of set B and sets A and B are not equal. So A and B can't be equal in order for them to be a proper subset. Okay. So, I mean, just real quick, we can see that those two sets there are not proper subsets. Okay. Because they're equal to each other. But let's look at an example on all that. All right. So write proper that it's a subset or a proper subset or both in each blank to form a true statement. All right. So for part A, we've got A is the set of all X such that X is a person and X lives in San Francisco. Okay. And then set B is the set of all X such that X is a person and X lives in California. All right, so for the first one, well, let's see. Well, we know, let's just look, we've got California right here. And I know that's not California. It doesn't look like it, but we're going to say this drawing represents the state of California. Okay. And we know that San Francisco, that's a state. That's a city in California. Okay. So let's look at this. If the person lives in San Francisco, then that means they're also in California, right? So every person that's in San Francisco is also in California. So we would say that this is what? Is it a subset? Or is it a proper subset? Do I use this one or just this one? Okay. Or do I use both? Well, let's ask ourselves this. Is every element of A in B? Yes, because every person that lives in San Francisco is also in California. So we could use the symbol this. It's a subset. Now, is it a proper subset? Okay, well, the answer to that is yes, because look, is the set here, San Francisco, the people in San Francisco, is that the same as the people in all of California? No, it's not. There's a lot more people in all of California than there is San Francisco, so we could use both symbols, either one. Now let's look at this one. We've got set A is 2, 4, 6, 8. Set B is 2, 8, 4, 6. All right, so let's look. Let's first see, are all the elements of A in B? Well, let's see. We got 2, so 2 is in B. 4, 4 is in B. 6, 6 is in B. 8, 8 is in B. So every element of A is also in B. So this is a subset. Is it a proper subset? Well, no, because if you notice, look, we've got 2, 2, 4, 4, 6, 6, 8, 8. Those sets are equal. So they're not a proper subset. Okay. Now, I know it did not ask for this symbol. I know it didn't ask for the symbol. But let's look at this. We could write this as, let's just do it over here to the side. We could write, let me write that better. Would that be a correct statement? A is not a proper subset of B. Now remember, keep in mind, this symbol, that's not the same as this one. This symbol here says that it's not a subset. Okay? What does this symbol say? This symbol says it's not a proper subset. Okay, so if you run across this symbol, that's all it means. It's not saying, this right here is not saying A is not a subset of B. It's saying A is not a proper subset of B. Okay, so I hope all that makes sense so far. All right, so let's take a look at this, the empty set as a subset. So for any set B, the empty set is a subset of B. All right, so what does that say? Well, that says it says that the empty set is a subset of any set. And then 2, for any set B other than the empty set is a proper subset of B. Okay? So the empty set is a subset of any set, and the empty set is a proper subset of any set, provided that set is not the empty set. Let me show you what that means in symbols. In other words, it's saying that this is not true. Okay? This right here holds for any set B unless B is the empty set. That's what it's saying. Okay? So here's an example. Let A equal. Now, if you remember from the other video when we went over the stuff with sets, what were the ways that we could introduce the empty set, or how we could denote the empty set? Well, that was a circle with a line through it, or we could represent the empty set with braces with nothing in it. Okay? That's the two ways that we could represent the empty set. So if A is the empty set and B is equal to 1, 2, 3, 4, 5, well, we can say A is a subset of B. And it's also, A is a proper subset of B. Okay. All right, so what about this number of subsets? The number of distinct subsets with n elements is 2 to the n, and the number of proper subsets, okay, so the number of distinct proper subsets of a subset with n elements is 2 to the n minus 1. All right, so let's look at example 3. And it says, find the number of distinct subsets and the number of distinct proper subsets for each subset, and list all subsets. All right, so first what they're wanting us to do is find out how many subsets and how many proper subsets. All right, so the number of subsets that is equal to 2. Okay, so remember this formula here, number of subsets is 2 to the n, where n is the number of elements in each set. So we have what? 1, 2, 3, 4, 5, and that's 32. So there's 32 subsets. All right, now we want to know how many proper subsets there are. Well, that's what? That's this 2 to the n minus 1. So that's 2 to the 5th minus 1. Well, 2 to the 5th is 32 minus 1, which is equal to 31. So that's how many subsets and how many proper subsets. All right, so for this problem, they want us to list out all of the subsets. Okay, and we've got to list out 32 sets. Okay, we'll see. I'll see if I'm gonna list them all out. I don't know. Well, I'll get you going at least. I may list them all out. So the first one that I always list is the empty set, because the empty set, remember, it's a subset of any set. All right. And then we have the set A, the set B, the set C, the set D, the set E. All right. So I just took each element and put it in a set by itself. See, A is a subset of that set. B is a subset of that. The set C is a subset of that also. And then what I do is I take the A, B, A, C, A, D, and A, E. So then what I did is I took the A and I paired it with each one. Okay? See, AB, AC, AD, AE. All right? And then what I'll do is I'll take the B and pair it with each one. So B, C, B, D, B, E. Okay? And then I took the B and I paired it with each one. Now you might be asking, well, why didn't you pair it with A? Well, remember, I already have the A and the B paired when I paired the A with each one. See this one right here. Remember, the sets are the same if they have the same elements. It doesn't matter which order they come in. Okay? So that's why we do that. And then I have to take the C and pair it with each one. So I've got C, D, C, E. All right. And then I've got D, E. All right. And then, oh goodness, there's going to be a lot here, isn't it? I don't even know if I'm going to have enough room to do them all. And then I'll have to do what? A, B, C. And then I'll do A, B, E. See, I took these two and paired it with the C. Then I took these two, paired it, well, let me write that as a D. Paired it with the D, and then took that, and then I'll take it and pair them, those two, with the E. Okay. And look, I'm not going to keep going with this, but hopefully you get the idea of what to do. Okay. I would suspect that the teacher you have is not going to give you a set with 5 elements in it to list them all out. you know, let's look at this just real quick. Let's do it with let's just make up a set. Let's do this. Let's say that this set here consists of the elements A, B, C. Okay? So we know that, let's see, the number of subsets, let's do this in green, subsets, that's what? 2 to the third, which is 8, right? 2 raised to the, and we got 1, 2, 3 elements. And we've got proper subsets is 2 to the third minus 1, so that's 8 minus 1, which equals 7. Okay? Now, let's write out all the subsets. Okay? So I'm going to start with the empty set. All right? And remember, I should have 8 subsets here. All right? So then I'm going to have what? A, B, C. I just used each one on its own. And then I've got AB, AC, all right? And then I've got what? BC. So I took the A and I paired it with each one. Then I took the B and paired it with each one. Well, I didn't need to pair the C with each one because, see, here the C is already paired with the A and the C is already paired with the B, so I didn't need to do that. And then the last subset would be the set itself. Okay? So whenever I'm writing out all the subsets, the first one I usually write is I write the empty set, and then the last one I'll write the set itself. Okay? Now, this right here, just writing this out like this, I think this might help you see why the number of proper subsets is this formula and the number of subsets is this formula. So if you look at this, see the proper subsets, it's 1 less than the number of subsets. Well, if we remember what proper subsets are, remember a subset, every element of that set is in the other set. But a proper subset says that the 2 sets cannot be equal. Well, if you look at this last set here, it's a subset, but if you notice this set and this set are equal, okay, so it's not a proper subset. So what they're doing, that -1 right here, that's just marking that last one off there. Okay. Oh, that's the last problem. This one is. All right. So what about the set of all x such that x is an element of the natural numbers and x is between 9 and 15? All right. So we need to see how many numbers are between 9 and 15. And notice with these inequalities, we are including the 9 and the 15 because it's less than or equal to. All right, so the number of subsets, all right. Well, how many elements are there? Well, let's see, we've got 9, 10, 11, 12, 13, 14, 15. We got 1, 2, 3, 4, 5, 6, 7 elements. Okay, 7 elements. So that's going to be 2 to the 7th. And let's see, 2 to the 7th, I believe that's 128. Yep. 128. So there's 128 subsets for this set. Okay, that wouldn't be fun listing all those out. And then we've got proper subsets. Well, that's what? 2 to the n, in this case n is 7 minus 1, which is 128 minus 1, which is 127. All right, so that's all of this video. I hope it helped. I hope it made sense. Check out all the other videos. I'm doing lecture videos on contemporary math, just going section by section out of a textbook. They'll all be in a playlist. I'll have them organized on my website. Check out all my other videos. Thanks for watching. Give me a like, share, and subscribe, and see you later.